All right, since we have a lot to cover, I'm going to go ahead and get us going today. As you might have heard me earlier, my name is Eva Rooks. I'm with Small Planet Supply. I'm the marketing director. And this is our webinar with Flowtech on SpacePak products. I'm going to go ahead and briefly introduce our presenters, go over housekeeping, and get us on our way today. As some of you may know, we had originally planned to host this webinar from Sonoma Clean Power's Advanced Energy Center. Unfortunately, because of Omicron, the Advanced Energy Center is closed to the public, but Chad Assay, director of the center, will give a tour of Advanced Energy Center at the end of this webinar if you'd like to stay and see it. Our first presenter today is Albert Rooks. Albert has spent 20 years in home component sales and buildings and has a passion for high performance building. And he ended up specializing in sourcing and importing components for these projects. In 2010, he founded Small Planet Supply USA. And in 2016, he expanded to Canada to help British Columbia and the rest of Canada meet their building goals. Our second presenter today is Zach Liskey. He was raised in Northern California and has worked diligently in various positions in energy efficiency, space, HVAC, and hydronic industries over the past 30 years. Identifying a market need for value-added product support and technical leadership, Zach founded award-winning Flowtech in 2017. Managing our Q&A box today is Daniel Torres. He is the DPG product manager with Mestech, the company that manufactures SpacePak. He has many years of experience with many Mestech lines, including SpacePak. Daniel will be working the Q&A for today's session, which will help keep things going quickly. Also on right now visually is Brighton Busick with Advanced Energy Center. She and Chad Assay are going to give us a tour. She'll be the cinematographer of the Advanced Energy Center later today. Chad is the director and she is the events manager. With introductions completed, just one or two housekeeping issues. First, as I covered previously, Dan will be handling the Q&A during Albert and Zach's presentations. Please use the Q&A box for your questions and not the chat box. I'll do my best to redirect, but that way we can have all the questions in one place. We will be sending out a follow-up email to you tomorrow with access to the PowerPoint presentation, and hopefully a video recording of the webinar will be available in about a week. So with that done, let's go ahead and get started. And Albert, do you mind going ahead and taking it away?
Great. Thank you. Happy to. Great. Let's key up a slide there, Zach, if we can move one forward.
There we go.
There we go. Great. Thanks. So welcome everybody to the SpacePak training. And we're going to return back to the SpacePak slides. Just a brief introduction of Small Planet Supply. The company has really been a passion of mine starting in 2010. At that time, kind of after the housing crisis in the U.S., I really wanted to do something different and had the good fortune to meet up with a number of builders, designers, and architects right around 2009, 2010 as the Passive House building performance model from Germany started reaching the Pacific Northwest and the rest of North America. And through that, I became really very interested in how tightly we can manage these buildings, improve the envelope, and pair them up with mechanical systems that will reduce the amount of energy that we need, change that energy into something that's fueled by electricity rather than fossil fuel, and see if we can, kind of keep them comfortable and managed without too heavy of a footprint on the mechanical systems. So with that journey, we started working with a number of new systems from Zender America, Sanco 2, the CO2 heat pump water heater just for single family water heating, and larger systems from Ventacity, and then created, maybe one slide forward there, Zach, the water drop system using these small CO2 heat pump water heaters to take over and serve all the domestic hot water needs for very large buildings. The building that we're looking at here is in downtown Vancouver, British Columbia. It's a 32-story office tower. And it used to be serving all of its occupants domestic hot water through gas boilers. And in 2021, the conversion was changed to an entirely electric heat pumps. And these heat pumps were the gang together Sanco 2s using a company built controller. And they're now serving this particular building for domestic hot water. Moving ahead one slide, we find that in order to move from fossil fuels to electric heat pumps, we're all going to be working with some form of a refrigerant. And heat pumps are really a good solution to where we want to go in making buildings perform in domestic hot water and heating and cooling using heat pumps. But all these heat pumps use some form of a refrigerant. The last building we saw use CO2 as the refrigerant. More commonly, I think we're all aware that most mini splits and VRF systems for small buildings and large buildings use some form of refrigerant like a 410A or a 134 that has a high global warming potential. And so the issue that we're facing through our electrification is as we transition into electric heat pumps, we have to be mindful and maybe try to make the best choices on the refrigerant lines. One of my favorite, and refrigerants are kind of complicated, and this slide was a learning event for me. One of my favorite refrigerants to replace the high global warming potential refrigerants in 410A and 134 was R32. It's a new synthetic refrigerant. It has a very low reported global warming potential of 750, which compares very favorably. However, refrigerants are all different, and the way we look at them is not a straight linear relationship. When we look at a refrigerant like R32 that shows a great promise, we see at a 100-year scale, the reported global warming potential is in the 750 range. Yet when we look at the actual lifespan of the refrigerant, if it leaks out of the equipment and into the atmosphere, it really dissipates and breaks down more on a 20-year scale. So when we start looking at the lifespan of the refrigerant in the atmosphere in a leak situation on a 20-year scale, the global warming potential pops back up to a very high number. So all I want to say here is that we need to use heat pumps. Heat pumps all use refrigerants, and refrigerants are complicated, and our industry is still learning about them. Thank you. Another situation is many single-family buildings and multifamily buildings use some form of a ductless mini split or even a ducted system. This is a retrofit that I did on a single family home. And we've got a large a 4-ton machine outside. We've got a number of refrigerant lines all fanning out to feed various boxes within the home that can provide heating or cooling. Between the outdoor unit and all of those individual head is a line charged with refrigerant. Forward one slide there, Zach. With a 4-ton system, a 4-ton system, and all the lines running, we calculated out that there's roughly 250 feet of line set carrying 410A refrigerant, which is a significant amount of refrigerant to leak in the atmosphere at the end of life, or if there's a small installation issue. What we do know is that these systems do leak over time. Leaks happen. It's very difficult to make a perfect system. And part of the global warming potential in refrigerants is through leakage is going to be a significant amount of global warming potential as we go forward with electrification. Thanks. Solution to this is to really switch to a hydronic system. A hydronic system means that we place a single heat pump on the outside of the building, and it contains a small amount of refrigerant charge, very, very small, within the unit outside. The lines and connections all stemming from that particular heat pump going to the inside of the building, whatever the emitters are all hydronic. They're water with a little bit of glycol. One slide forward. So in the upper left-hand corner, refrigerant is in the heat pump outside of the building only. From that point forward, the connection is all water to a small buffer tank inside the building. And this could be a single family, it could be a multifamily. And from that buffer tank, so the heat pump and the buffer tank are constantly communicating. And the heat pump is charged with keeping that buffer tank at a fixed temperature. And that temperature could be a warm temperature, it could be a cold temperature. It depends on if we're heating or we're cooling. From that buffer tank out to all the different emitters, it could be an air handler, like middle picture in the top, which would be taking warm fluid or cold fluid, turning it into a emitter right behind the fan coil there. We blow air over it, and then we blow that conditioned energy across the building. Upper right-hand corner is a wall-mounted unit. Lower right-hand corner, standard PEX in a floor slab, and then middle picture in the bottom is just the standard head that we'd use on a ducted mini split. All of those can do some form of heating and cooling. The slab can also be used for cooling. It's just a bit trickier. And as we learn more about this, I think we find ourselves in a very safe position that we can move to a hydronic system. Hydronic is, easily 100 years old. Lots of people know how to use it. It's very reliable and can be serviced in a long period of time. We can see in the upper right-hand picture around the library area, there are small holes. That's a small diameter ducted system. So there's an air handler behind that one. The picture below, we've got a kind of a high wall head on a wall there, and by the door we've got a wall-mounted head that's got a fan in it, and so we get a little bit of a radiant boost off of it and a little fan energy. These are systems that all use some form of fan or radiant energy, and let us use a hydronic system rather than a refrigerant system. Because really, when we look at it, refrigerants are going to be a handy thing right now. We can do it. There's a whole industry that can supply it, but it does have some long-term problems. And those problems are really removed by working with a hydronic system. Forward. Yep, good. And more solutions coming. So we've got more kind of top-down radiant solutions coming, as well as another system originating out of California. And forward there, Zach. Great. And then right back to a simple monoblock. This is really where Zach's going to start picking up after this. Simple monoblock heat pump using a hydronic system. Heat pumps outside. We've got a buffer tank in the basement, and the buffer tank feeds into zone control, and zone control feeds into whatever emitter that the particular project would like. A very simple system, very reliable, and friendly in warm climates and cold climates. So with that, I think I'm ready to turn it over to Zach. My part in this is just to say that hydronics are something that we really want to consider for reaching the climate goals that we have. Thanks.
Thank you, Albert. This is Zach Liskey with Flowtech. I'm the founder and president here, and I really appreciate the introduction. Great job showing that. Pleasure to be here to support Small Planet with the SpacePak presentation. Big question we get a lot is, will we have these slides available? And the answer is yes. And even better than that, there'll be some bonus material in the slide deck that gets emailed and communicated back out. So some of the wiring diagrams and deeper detail is hard to communicate on a Zoom. And also, for the interest of time, we'll be sending out a slide deck with some bonus material after the presentation. I want to mention we're supporting Small Planet here, and there's a number of participants from different areas here. So this slide's showing kind of who your manufacturer support is by region. If you're in our area, which is California and Nevada and Hawaii, we're your manufacturer rep and supporting a Small Planet. If you're up in the Pacific Northwest, Alaska and British Columbia, it's Proctor Sales. And I think there's some people who are in other areas as well back east. So SpacePak has a rep locator website that you can go on their website and find out who your local SpacePak representative is and are in those areas. So happy to be here. We're going to be taking a overview look on all the SpacePak family of products, focusing on the monoblocks as well as a few low ambient offerings that SpacePak has presented. One of the resources, valuable resource as you're developing projects, doing your own projects and getting ready to design is the SpacePak pre-sales team. I should have mentioned also, we're lucky to have Dan Torres moderating the Q&A here. He's applications, he's a product manager for Mestech and product manager for SpacePak. So be sure to throw your questions in the Q&A. And if you don't get them answered today, based on the volume, we'll get back to you for sure. So back to pre-sales, questions about the application, design criteria, suitable product for a particular project, please reach out to this phone number and email for pre-sale support. In addition to your rep, they're a great service and support also for our SpacePak products. Getting into sort of the nomenclature, it's a funny thing that people, it's a little bit, I say tomato, you say tomato, heat pump or chiller, what is the terminology? In fact, they're the same. Likely if you're in the Northeast, you might be called a heat pump. It's common language. And if you're in the Southeast, it's a chiller. Out West, we're a little different. So we always do things different. We call it a hydronic heat pump. But the good news is that it's all the same thing. So these units are outside. They provide heating and cooling depending on their mode of operation. And so it's kind of a funny thing to engage with a little bit too with people when they're talking. Here's an exploded diagram of the equipment, the SpacePak units here, and air-to-water heat pumps in general. And a heat pump doesn't create heat. It uses electricity to gather heated energy or cooling energy. In our case of the monoblocks, it's injecting it into the water stream and pumping into the house. So it's really, a heat pump is really the right term because it's pumping energy and it's using electricity to do so. So in this situation, we're in heating mode, and we're gathering, compressing refrigerant and then running air across the evaporator coil and kind of robbing or gathering heat energy and injecting it into the water stream. In the bottom left, you'll see if I can get my pointer here. Yeah, right here is that Trident, that's a reversing valve. So in the summertime, it'll go into cooling mode and it operates in the opposite direction. And you're running refrigerant over compressed refrigerant over a coil and gathering some cooling energy, even though it might be warm outside. You're able to gather some cool energy to chill water and circulate chilled water to and from that buffer tank. We'll get into glycol percentages and some other design criteria, but this is overview of kind of what's going on in the box, so to speak. So this is the SpacePak family of products. Really proud to be affiliated here and representing and promoting SpacePak, as they have some of the best, most robust options. And also, chances are, if you have an application, SpacePak has a solution for you. So I'll just go over I'll go from the bottom left here. Out in our neck of the woods, this is our daily driver, our workhorse. This is the monoblock, SpacePak monoblock, 3-ton and 5-ton unit. We'll get into monoblocks versus split units down the road in the presentation. To the right, we have our buffer tanks, different sizes on the buffer tanks, which are very important parts of the design and the system that are integral to correct operation. This little icon indicates low ambient. So these are 2 low ambient solutions that we have. Award-winning low ambient solution all the way to the right is the SpacePak split system, and we'll go into detail on that. Coming soon, the next member of the family here, hopefully late Q2, early Q3, is going to be the monoblock low ambient. So it'll have the advantages of low ambient performance with the monoblock, the benefits of having a monoblock. So really excited to add that to the mix as well. Up top, Albert mentioned the terminal units, the high wall and thin wall units from SpacePak, and we're just introducing it here. And one of my favorite things to talk about is the SSIC control. And we'll get into that as well, kind of tying all the system components together. And Albert mentioned too, the hydronic fan coil, which we'll get into. So that's the overview of the products. And now we can jump in and take a deep dive. Starting on monoblocks. Why do we love monoblocks? There's many reasons, and Albert touched on a few which are repeated here. And no refrigerant in the occupied space. Overall, reduced refrigerant, greatly reduced refrigerant in the system. There's another component to this too, which is human health and comfort. When refrigerant leaks inside the occupied space, there's an element there of safety issue for folks. Electrification is taking over in our neck of the woods and in other areas. And as we do this, it's going to be important in a rapid way to retrofit old buildings out of carbon sources. And to do that, we're going to need all hands on deck for technicians. So when you have a monoblock, there's no need for a refrigerant license on that. A plumber hydronic contractor can install these with basic plumbing practices. It will be helpful to get these projects retrofitted and new construction just in terms of scaling. So it's a big benefit of the monoblocks is that it reduces the technical aspect and the licensing of the installer. Thermal storage and demand response. I've got a slide on this and I'll talk next on that one. But here's the big one too with this is all the things you can do with the monoblock heat pump, even the split unit, is the heating, cooling, and domestic hot water from one outside appliance. Domestics, got some considerations, but at the very least, a preheat for domestic hot water, heating and cooling, all from one outside appliance on a very low amp draw. Big benefit of these units. Thermal storage and load shifting. We do a lot of work with third-party utility CCAs, and the big concern as we migrate projects and our whole infrastructure to electric sources is the demand that it places on the grid. So our SpacePak monoblock systems can do a great job of storing energy when it's a low demand period, and then using that on site to reduce the demand and the impact on the grid. This is a kind of a good example of that, maybe slightly extreme, if you will. There's 600 gallons of storage heated up during the day and utilized heated up at night off peak and utilized during the day when the demand is high. So utilities really like these systems, and I see this, and I'm seeing this as a way that hydronics as a method it will be becoming more and more mainstream as we move into electrification. Another great advantage of monoblock heat pump systems is placement of the outside unit. We're here, our territory is California and Nevada and Hawaii, but in California, it's very difficult in some very densely populated areas to place the units there. And so being able to have some flexibility on that is great. These can be placed further away from the house than traditional equipment, provided the piping and the pumping so big advantage is flexibility and placement. So COP, talk a little on COP as a measure of efficiency of heat pumps. So as mentioned, heat pump transfers heat from the outdoor environment and pumps it into the home. It's not necessarily creating heat by burning anything, obviously, and it's gathering that free energy that's outside. And you see on the graph, a 1 unit in and a 4 unit out is a COP of 4. 1 unit of energy into 1 unit of output energy is a COP of 1 or 100% efficient, similar to an electric resistance heater. If 1 unit of energy in to 4 units of energy out is a COP of 400% efficient, pretty phenomenal. Our units are inverter, and we'll get into COP, but the inverter capability of our units allow for some high COPs. This is a really, how do you design these systems and sort of some considerations. Unlike a natural gas product where you're always getting the same BTU output, mostly if you're at elevation might affect that, but you have 100,000 BTU boiler, it's going to give you that. Heat pumps are different, and it's very important to understand that this left column here is ambient temperature, and that's will be impacting the capacity of the unit as well as supply water temperature. This chart assumes an 86-degree return water temperature. And so when you're sizing these units, understand what your local conditions are for your design day, the average coldest day of the year. And if you're designing around 45 degrees, you'll be getting 70,666 roughly. And likewise, if it's a cold climate and you're designing around 5 degrees, your B2 output will be reduced on that. So sweet spot for radiant hydronic is SpacePak. SpacePak sweet spot is between 100 and 125 degree water temperature. And it just so happens, luckily, that that's very common to a great application for many of the distribution methods that we see in hydronics, all the way from, radiant floor heating to underfloor, wall and ceiling radiant panel radiators, SpacePak or conventional air handlers. All of those methods will be well suited to be paired up with a SpacePak unit. So they're applicable to a wide variety of existing and new construction techniques. What is not a good fit are high temp. So high temp cast radiators or baseboard applications. We saw this slide previously. Just touch on it quickly here. It shows you an overview of the system with the unit outside feeding a buffer tank, and from there, conventionally piped to terminal units, radiant floor heating, or fan coils. So we'll get into the monoblocks, our daily driver, our workhorse. Been phenomenal performance in about a year and a half, 2 years of seeing these out in the market. We were lucky enough to help roll them out in our market. So there's the 3-ton on the left, the 5-ton on the right. That's inverter compressor that allows the units to modulate, ramp down their output to match loads. Got a touchscreen control. Quiet operation is a big one out here in many areas. Get that question a lot. These units operate at the loudest they'll ever be is 56 dB at 1 meter. And I've tested that with our dB meters. But the good news is when they're inverting and they're at a part load, they're even quieter. So they've been really quiet on that. No field refrigerant. Low amp draw is another big advantage. When you're electrifying a house and you're taking it, an existing house or a new construction house, and sizing your panel, it's nice to know that your heating, cooling, and domestic will be requiring maybe a 30 amp breaker, maybe a 35 amp breaker, and the running amps is 21 amps. That's a big advantage of these units versus other electrification equipment. 5 years parts, 10 years on the compressor. At the end of the slide, I have some information about certified contractors and registering your products for warranty. And we'll get into that here too. The touchscreen control is a feature of the SpacePak monoblocks that are out, and also the split unit, which is a differentiated feature. It's not another the types of equipment out there, and it's just a really handy and effective tool. This is a way for technicians to program the unit on startup, adjust water temperatures, set the mode, and it gives you some really great diagnostics. You can see on the right and the left, those circles are your supply and return temperatures, so a technician can see exactly what's happening with the temperatures of the unit. Going into the menus, there's no coding or service addresses. You can see what the pressures are. The compressor can show you fault codes and whatnot. This touchscreen can be located either in the mechanical room, or it can be disabled or taken out to the unit to program the unit. And it allows the technician to be able to monitor what's going on with the SpacePak, with the outside unit, when he or she is in the mechanical room commissioning or maintaining the system. So it's a really, really neat tool. Overview slide here. And like I mentioned, we're going to be sending all this slide deck out for all the detail, but the high points here to touch on is the capacity based on temperatures that we talked about. Always understand your local conditions. One thing that's very important to note, and I will kind of reiterate this throughout the presentation, is the pressure drop on the units are higher than a lot of technicians and contractors are accustomed to on piping equipment. So on the 3-ton, it's just the unit itself is 13 feet of head at 7 gallons a minute. The larger unit is even more. So it's one of the common things that we're seeing a lot is undersized circulator on these units. And so make that special attention to understand this pressure drop through the unit. Sizing of the units is the kind of the very similar footprint. This is a 38 by 18 by 35, and the 5-ton unit is taller, but the footprint stays the same. We mentioned the touchscreen control. The units come with a whip, a 65-foot whip with the connectors on it, and it also can be field supplied. If you have a longer run than 65, you can go and field supply some the proper wire for the application. All the connections are on the right side, and we'll get into some photos which show that too. The good news on these units is that they're very simple. They're complex when you look at them. You look at the control board, but for installation, it's really installing your 230 volt power. We need 4 wires on these units because they operate the circulator. So this 4-wire 230 volt single phase. And just keeping it simple, this is the wiring on the side of the unit for both the 3-ton and the 5-ton. And I've had customers, in a very simple way, they're turning it on and off with a dry contact, closed contact on an end switch, and they have it either jumpered or they put a heat cool toggle switch in the mechanical room, set the water temperature, and away you go. So this is these are the wiring connections on the side of the SIM units, and it's very simple to do. You'll see this as well in future slides, the basics on SpacePak's monoblock and split systems here, feeding a buffer tank with a 3-ton unit. As I mentioned, this circulator pays special attention to sizing that circulator. Common error we have is common fault is that it's undersized. We have the pressure drop through the unit. We have the piping. We have a glycol percentage D rate. So make sure that is sized appropriately, feeding the unit and feeding the buffer tank. Buffer tanks are real important. I'll just touch on it here. Buffer tanks on SpacePak systems do 2 things. They provide some system volume, but the real benefit, which is critical to efficient operation, is it decouples the flow rate from the system, whether it's radiant floor or high walls, thin walls, air handlers, decouples the needed flow rate for the system and the needed flow rate for the SpacePak. This 3-ton SpacePak requires 7 GPMs a minute. And so that buffer tank allows both the heat pump to get what it needs on the flow rate and the system to get what it needs on the flow rate, and make sure everything is operating well. Here's some installation shots. I joke that the heat pumps have the best views on our jobs in the city area. They are always on the roof with the ocean view or the bay view, and don't get to enjoy it. So the one in the middle is one of our projects. It's a 3-ton unit. Going in there, and then some other applications. On the left, it's up on a rack, keeping it up off the ground. We've got some cold weather requirements too, is to keep those units up so that the snow does not build up below them. We'll go from there. 5-ton unit, very similar. As mentioned, I won't spend too much time on this. The pressure drop is much higher. This unit pressure drop 23 feet ahead at 13 gallons a minute just through the unit itself. So that is quite big. So we're going to make sure to pay attention to that. Little mention on the glycol. We have people from all over the country here today on the presentation. So in our neck of the woods, we're using 15%, 20% glycol. Use what's local to your area based on your temperature in there. And we can, it's very important as well, not just for low ambient protection, but for protection of the equipment when you're in cooling mode. So the equipment's very sensitive to cold. So the glycol is essential. And if you're anticipating potentially getting any warranty, not that we've had those yet, but down the road, glycol is mandatory for system performance. Very similar slide here. You have your touchscreen control. What's nice is between the 3-ton and the 5-ton, a lot of the touchscreen control is the same. A lot of the parts are the same. In fact, we replaced a control board between the two, and we just had to change one parameter for the extra fan. So a lot of the parts are used on both units. Once again, field wiring here, 230 volt side panel, and then very similar here. Field wiring for the 5-ton unit is the same. And the buffer tank here is showing the 5-ton unit is feeding that buffer tank, but same concept. So we wanted to focus on the low ambient, which is newer for us. I believe 4 to 5 months it's been in the market. This is very popular for us in our low ambient areas. So this takes the function of the monoblock and splits it up into an indoor unit and an outdoor unit. And in between, you have a maximum of 35 feet of line set. And so the low ambient gives us a great performance. It also helps with the antifreeze protection, not needing as high percentage of glycol. And the indoor unit kind of pipes up like a wall hung boiler on there. This unit was mentioned with Redwood Energies as a national electrification consultant and publishes a all electric design guide. This unit was mentioned as best in class low ambient performance. At minus 20 and 120 degree supply water temperature, we're getting 33,000, roughly almost 34,000 BTUs. So pretty phenomenal low ambient production on this product. A little bit more on the wiring here with this. So you have your indoor and outdoor module. You also have a communication between your indoor and outdoor module, which is all supplied with the unit. And I should have mentioned the line sets come with the unit. It's a package, so you don't have to locally source those line sets. And that's a nice feature, as it comes all as a package on that. Okay, we're doing good on time. So I'll spend a little bit more time on this as it's somewhat different. Similar concept with the buffer tank, but this is showing the outdoor unit and the indoor unit. And in here, you have your refrigerant line sets that come with the package. Maximum line set is on 35 feet on that, feeding into your indoor module, and from there, water connections to the buffer tank. You will need to size circulator for this. It's not part of it, so size that circulator for your. The unit itself is 24 feet ahead at 12 gallons a minute. It's very high head situation too, so make sure you size it correctly. So this is showing some other, and we have other design slides we'll get to as well, but this is showing adding a boiler, and the boiler is on there for possible backup protection at low ambient. Oftentimes engineers will size the split unit for part load, and they'll catch the really low temperatures with a backup boiler. Some folks like to see a backup boiler on there for redundancy as well, so they have another source that they're not only relying on one piece of equipment. I will be talking about my favorite thing to talk about is one of them is our SSIC control. That's a really neat feature too that operates that boiler in backup mode and different things. So we'll talk about how to control that as well. But this is a common design for a low ambient with the backup boiler option. Some pictures. This is, I think, back east where they're doing some zone pumping by zone. So you see a lot of circulators there, and the indoor unit, buffer tank, expansion tank, one of the large houses out there. And as you can see, it's all laid out pretty nicely. Some more application photos here. I mentioned it's very important on the split units when you're in low ambient to get them off the ground. The units, both the monoblocks and the split units, they weep condensate. The condensate doesn't need to be treated. When it goes into defrost mode, there's quite a volume of water that comes off the units. And so when you have an area with snow and freezing conditions, you want to be able to get those units up off the ground. And so it doesn't get buried with the buildup on that condensate. More photos here of indoor and outdoor applications. It looks like it's indoor, but it's outdoor on this one. I'm not quite sure on this. We'll talk about placements here. This is outdoor clearances. Clearances are important for all of the products, and maybe a little bit more than, say, traditional compressors and whatnot. So on this, we'll need 72 inches off the front. This slide deck will be presented. You'll need to take notes, but it's very, very important that you place these correctly with airflow, proper airflow requirements around the back and the front. It will not operate correctly if you don't. And also for clients to make sure that we're not, they're going to build some kind of baffle or screen or, a visual screen or some vegetation. So we want to keep them clear and have access to air. This is the SIM unit, 40 right, 20 off the back, 20 off the left, and 60 off the front. So everything, this is an older model, a legacy product for SpacePak. This is pulling in the cold air off the back and hot air is coming off the front. You never get what you want. When you're commissioning a unit in the winter, it's blowing cold, and when you're commissioning a unit in the summer, it's blowing hot on you. So as a technician, it's one of those things. We'll talk about multiple unit installations here. The big takeaway is you don't want one unit blowing into the other. It will reduce performance on that. So make sure you either go back to back or side to side with the proper clearances there. Evacuating condensate. This is a sim unit. This is one of our beta tests, and there's two little ports, barbed ports under the unit, so it can be used to get a condensate drain out. I've had some contractors will put a decorative drain rock around it, like a kind of a box of decorative drain rock, so the condensate can get in there and have time to evaporate. But just something to consider, especially if it's in a public area with the walkway, that it's a good idea to take care of that condensate. Multiple unit applications. This is coming up more and more. Older picture here, but this was a church back east. I think they had a 2 million BTU boiler turning on. That's great on Sunday when everybody's in there and you have a high heating load, but not so good when the pastor's in on Wednesday and they're not using that much. So they replaced that with a stack of SpacePaks here, feeding a common loop, supply and return loop, and it gives them a great, much more efficiency, much more staging, and they were very happy with their installation. Similar here on the left is a commercial application. On the right is a kind of a high-end custom, very large residential project where multiple SpacePaks were installed. Cold weather application. Very common question we get, hey, when do they shut off? They don't. They never will shut off. As we understand, they just ultimately reduce, and at some point at ultra low temperatures will equal a COP of 1. But they always will contribute that, at least that. So the couple of case studies, the one on the left is a research station where our old low ambient replaced some existing equipment that had failed, and that kept that classroom warm all winter. I think this was in Antarctica or some really extreme climate. So we'll get into, take a pause here for a drink of water, and we'll get into some other components of SpacePak offerings. All right, so this is back to our original house diagram and showing the outdoor unit feeding the buffer tank. And we will get into a deeper dive on the terminal units, with some flexibility on design, and we'll get into some more design questions as well. Back here, we'll start with the air handler. So SpacePak got its start with inventing and selling high velocity air handlers. They are easy to get into architectural places that, like modern architecture, is very difficult to get ducting. The SpacePak air handler and high velocity system is a smaller ducting requirements. This version is a hydronic, so it's taking that chilled or heated water from the buffer tank and delivering a heated or cooled energy to the house between 2 and 5 tons. And you can see some data sets here. For me, it's easier to show with pictures. So this is the air side distribution for SpacePak. And a lot of times we see these in combination with radiant floor heating, as maybe we're cooling the upstairs. So we have a lot of design flexibility with hydronics, which is one of the things that I really love personally. It's exciting to be part of. So what we're showing here is our fan coil unit. Got a condensate drain, and it feeds into a 9-inch or equivalent branch ducting. And from that 9-inch branch ducting, we have flexible 2-inch mini ducts that go and thread throughout the house. You can get them through top plates. It's much easier to place them, and then into these distribution and outlets that you'll see. And I have some slides on that in a bit. The last 5 feet, the last section, 3 to 5 feet, is sound attenuation tube, and that allows the unit to satisfy the sound requirements, and that's a very important part. So this is just another option for design, adding cooling and heating in a way that is easy to fit in modern architecture. Got some photos here, which you've seen before. So really clean aesthetics from a design perspective. All you're looking at is what looks like a, kind of a recessed light, hockey puck kind of thing. So you're not seeing any big grills. It operates well. You can also put these on the floor. You can put them they can be terminated on the sidewall. They can be terminated under a toe kick cabinet. So there's a lot of flexibility on where these come into the house. Moving on to our hydronic high wall fan coil. Albert mentioned this too, and these are great options. I can't tell you how many times I have designs that come in and I see a SpacePak specified for heating, whether it's radiant or thin wall units, and then a whole separate system for cooling. Mini split system. They got the outdoor unit, they got the line sets, they got the high walls. And then we show them, hey, you can do the same thing with what looks like a high wall from a mini split and eliminate that outdoor unit. So this takes that heated cool energy here and then distributes it through different areas in the house where these units are placed. It's remote control, but there's some different strategies on simplifying these control of these units, and they do a really good job of providing that cooling and heating. I want to make a note on design for these and other units for SpacePak. Flexibility in design is a key thing. I'm showing here that your outdoor unit capacity will, if you change the unit, the unit you choose can change your capacity and your efficiency. So if you're going with what our small one, the SpacePak 06 here, it's a smaller unit capacity wise, and you say you had an 11,000 BTU load or close in trying to satisfy in a room, and go with the small unit, you're going to need to run 140 degree water. That's not even really an option with our SpacePak because we'll go up to 125. But you can upsize the unit. It's a minor cost to upsize a unit, and you're able to drop your water temperatures down to 120 and still satisfy that 11,000 BTU load. The physical dimensions on these units are all the same, so it's not like it's going to take up more space. I say this because it's a design strategy. Is the goal to reduce that water temperature, and similarly, you could even increase more to get down to 110 degree water. Once we drop those water temperatures, our outside SpacePak unit is operating much more efficiently and has a greater capacity. So design flexibility, have a look at that. Moving on to the thin wall, a little bit newer for SpacePak. It has a nice clean aesthetic as well. Glass front, touchscreen control, very quiet operation. Fairly simple to install, great retrofit solution. In our area, we're seeing these installed where you're not doing full cooling of the whole house, but certain times of the year, it's nice to have some cooling for the master bedroom, so it doesn't have to be a whole house cooling system. It can just be in some areas. Very important here too. And similar concept, you'll see the connections here on the left, 1-inch connections here on the left. I believe on that. And then, design flexibility. You're needing to satisfy an 8,000 BTU load. You can do that with 160 degree water, or you can increase your unit here, unit size slightly, physical size raises, but now you're down to 120 degree water temperature. So it's a great efficiency to look at sizing. Faster. Get into buffer tanks a bit. Buffer tanks, as mentioned, are critical components of the system. They allow to decouple the flow rates from the outdoor unit and the system. My nickname for this is the best value in hydronics. These are amazing units. They great value. The key component, they have electric elements that are on board for use, whether you employ them or not. All the buffer tanks come with electric elements. Our small 13-gallon unit comes with one single 3 kW element. The units from 26, 40, and 80 gallons come with 2 elements. And these elements are great for backup heating. Oftentimes, we're on the cusp of needing 2 SpacePaks on a project, and utilizing these buffer tank elements for backup heat is very important. Perhaps it allows us to not add a second unit outside. So for the coldest days of the year, the sim unit will call on the elements here in the buffer tank to boost the heat and cover the load on those cold days, and it works really well. There's a great logic in the sim unit for turning these elements on. It's also a stainless steel tank, so great for cooling, insulated. and has a 10-year warranty. So it's a really great option for us. The connections on these are, I believe, 2-inch connections, and then on the large one it's 2-inch, and on the smaller ones there's 1.5-inch connections. Buffer sizing for design criteria. In the old, not in the old days, but previously, your buffer purpose of a buffer tank is really to reduce your short cycling of your equipment. The inverter monoblocks and the inverter compressors that we have on the heat pumps now, they will ramp themselves down to match the load. So if there's a 50% load on the structure, the unit's going to ramp down to 50%. The impact of that on buffer tanks is that we can get away with a little bit smaller sizing on the buffer tanks. And one reason that SpacePak has brought out their 13-gallon buffer tank, which is suitable for even a 5-ton heat pump, as a option for purchasing. One thing to note is system capacity will also impact the buffer sizing. So if you have a super high volume system and you need stored BTUs, high volume BTUs to be a fast response situation, that might impact it. But otherwise, we can get away with a little bit smaller of a buffer tank, which is very helpful for tight spaces and whatnot. So DHW is a question that we get asked a lot. As I mentioned earlier, domestic hot water, heating and cooling all from one outside unit. There's no real silver bullet with heat pump water heating for the domestic side. SpacePak does a great job of this. How it works is that the unit has, I'm looking at the sim unit here, and don't believe the DHW feature is available on the split, on the low ambient split unit, but if it's a monoblock sim unit, both the 3-ton and the 5-ton, has a DHW priority call, much like a condensing boiler where you have a DHW priority. So in normal operation, whether it's heating or cooling, the unit's feeding the buffer tank. And when it gets a domestic call in this application, and there's variations of a theme on this. If you're in our territory, please reach out to us, because we've taken leadership on the DHW integration, and you can see this is an approved design that we've put together to help contractors and engineers put this together. SpacePak operates this diverting valve, and it feeds the external flat plate heat exchanger and feeds an electric water heater with a backup element. I think the two top takeaways here is, number one, backup is critical on these with the element and the water heater to hold the floor up and provide backup heating. And the other one is it's critical to use an externally sized flat plate heat exchanger. I get asked a lot from my technicians, hey, I've got an indirect here. There used to be a boiler. I just want to run it into the indirect, and it's not going to work. It's a bad situation. Won't deliver the heat to the unit, and then the SpacePak starts to think it's satisfying the load, and it will ramp down, and you'll never satisfy that domestic load. So it's real critical in this application to use the external flat plate heat exchanger. So yeah, if you're in our territory, definitely reach out to us, and we can help with some of these features. Variation on a theme here too is, if you're in an area of the country where electric resistance is maybe treated better with energy modeling or local codes, out here we have some constraints with modeling the electric resistance and getting it approved through code. We're going to need to change that, but right now it's a challenge. This one operates very similar, where we're running into a diverting valve into a flat plate heat exchanger, but we're using a modulating electric tankless unit here. And the benefit with that is it's only going to boost what's needed. If you're sending 105, or say you're sending 110 degree water to it, it's going to take it from 110 to 120. It's not all on. So it's going to modulate down and just provide the extra energy to boost that water temperature up in line. It also avoids an extra tank. So it's a nice clean design if this is approved with local codes and energy modeling. Make a plug here also for folks listening from our neck of the woods, is we're high advocates with the energy modeling and understanding how that works. It's new equipment, and the energy code isn't really catching up with electrification very quick. So there's certain best practices on how to model SpacePak units to gain compliance and to get them into projects. And so we can we're not engineers, but we talk to a lot, so we know what some of the best practices are for getting these through the energy modeling. So reach out to us on that. Layout, piping considerations. We talked pressure drop. That's basic hydronics, is understand that your glycol and your piping will impact your pressure drop. So these are some older design documents. Just we'll kind of go over it. Repetition helps gets us up to speed. This is our older unit, but the design is going to be the same with our new units. And really, this is just your basic system, feeding buffer tank with expansion tank, and you can see what's going on here. Glycol is important for this. I wanted to show, this is back to our applications, how well suited the SpacePak is for different applications, and we'll go through some of those right now. I always like to think of it like there's a big line right through that buffer tank, everything on the SpacePak side and then everything on the system side. And nothing really changes on the system side just because you're using a heat pump. It's basic hydronics. We're feeding right here, radiator valves on here, baseboard stuff with the manifold set up. Here we're showing it being pulled into panel radiators, and through manifold setup as well. So any of your distribution methods we talked about, these are some examples of how nothing really changes just because you're using a heat pump. It's still just hot water from the buffer tank feeding these applications. In this application, it's a radiant floor heating with the actuators, zone thermostats, and actuating a manifold here. And once again, this is the critical on the buffer tank function is to decouple that flow rate. You still need 13 gallons a minute in your SpacePak unit, but maybe it's just the master bathroom that's calling for heat, and so you've got a 1 gallon a minute need on the system side, and the buffer tank is what's managing all that. And without that, the systems won't work. Getting into a little bit more complexity, one of the beauties of the units is they're doing heating and cooling, and this is showing a basic heat cool system. You got your unit feeding a buffer tank, and in the wintertime, you're running it through radiant floor heating or panel, floor panel or wall panel in there. Summertime, flips over into cooling mode, running it through an air handler, SpacePak air handler, or conventionally ducted air handler in the cooling mode, and you're keeping that water temperature chilled. I should mention too that what we're seeing too, radiant now is becoming optional with a lot of projects. It's interesting to see that people are elected to use these units and not have radiant heating. We have a conventional ranch house with a forced air furnace and a gas water heater can be replaced with one of our units and run right into the air handler. So they don't have to be complex, expensive systems to be applicable for our products. This showing 2-unit installations. Oftentimes we're using 2 SpacePaks out there to satisfy the load. A couple of key pieces here is a piping diagram for that. We've got some others as well. Key point here is to utilize the individual circulators for each unit. There's antifreeze protection protocols, and there's reasons why you need the SpacePak to operate its own circulator. So there's a 110 line voltage from each of those units coming into its own circulator. So when that unit calls on, it turns its own circulator on. Or if there's an antifreeze protocol happening, it'll turn a circulator on and recirculate buffer water temperature through the unit. Oftentimes I get questions, hey, can I just keep that circulator on, through a zone control or not wire it to the unit? And we don't like to see that. So 2-unit applications. We've got other piping diagrams too, reverse return for larger commercial stuff. If you have a commercial application, reach out to, if you're in my territory, reach out to us and we'll get on with the pre-sales from SpacePak to go over your particular application. Insulate. Often folks insulate for energy efficiency, but with the chilled water, we're insulating for condensation control, and it's a different, right? So you really have to go back and you think you've insulated it well. You can see this one on the left, hey, that looks pretty good. Well, every one of these stems is going to drip this manifold is not insulated. The pump here, so there's areas where even if it looks good, is not. So very important to insulate well. I have actually a subcontractor who insulates some of our mechanical rooms because it's growing. The need to insulate is growing for sure. And another strategy here is to possibly do some dehumidification if it's a mechanical room. These are obviously very complex equipment systems. They don't have to be. They can be very simple, but insulation and condensation control is very important. How are we doing on time? We have about 15 minutes, so I think we're doing pretty good. One of my favorite things to talk about, the SpacePak SSIC. I call it the Swiss Army knife. It's got lots of different features in it and can do a lot of different things. The full slide deck we send out will have wiring diagrams and all kinds of detail, but I like to talk in pictures. And so this is kind of showing all the different aspects that the SpacePak SSIC can control or integrate. At the very basics here, at the very basics, it's taking a field calls from the field. So you have an air handler, like right here, we have a SpacePak air handler tied to a thermostat, or perhaps a zone control from a radiant floor heating system. It's landing up to 5 zones of heating and cooling calls. Those are 24-volt heating and cooling calls from the field. And I don't know why this image changed. It had a new unit in there. This is our older unit, but nevertheless, the SSIC will turn the unit on when appropriate. It'll turn it into the correct mode, whether it's heating or cooling. So it provides that critical switchover from heating to cooling mode based on calls from the field. That's the basic step there too. Additionally, the SpacePak can manage outdoor air temperature and manage a buffer tank seasonally. So we're setting up a buffer tank management. So for the summertime, and if the temperature is above 70 degrees, then this is all configurable. It can manage that buffer tank for chilled water. And in the wintertime, when the temperature is below 60 or below 50 or below whatever you set, it can manage that buffer tank to heating. And then it creates a dead band in the middle for efficiency. So it's managing a buffer tank seasonally. It's taking calls from the field. And finally, it does a really good job on this boiler backup. So the SSIC can call a boiler on as a backup in help mode. For example, you can program it where if the SpacePak unit isn't keeping up, maybe it's a design day, there's a cold temperature and the SpacePak's not keeping up, or you've designed it so it is not keeping up. The boiler will come on, provide help, and get that buffer tank heated up appropriately. You can also set it up so that the SSIC calls the boiler on no matter what, under a certain temperature. For example, under 10 degrees, you just want to be on boiler operation. It'll call that boiler on as well. So a really great little control. It does a lot of different things for us. There's some other elements too that it does, but these are the top level ones. Coming soon, I'm excited that SpacePak is upgrading this control, and soon to be released on the next version of it is a staging control. So it will be able to turn the outside units on if there's multiple units and stage them for equal runtime. Second exciting update will be outdoor reset curve on the SSIC. And the good news is if you've got one installed already, you can still take advantage of these upgrades. It's a firmware updatable, so it's easy to drop a new program on an existing in-place unit. And we're looking forward to that update for the SSIC control. Here's a diagram here showing the control board, and we can get into it too, but your outdoor sensor plugs in here, buffer sensor here. These are your zones, your heating and cooling zones over here, and your reversing valve right here. So this will be what tells the outside unit to go into heating or cooling mode based on the call. I think we're getting there. Kind of ahead of schedule a bit here. Maybe we ran through them quick, hopefully not too quick. SpacePak pre-sales team is a critical, helpful group here for designing projects in conjunction with your rep support for Small Planet Supply. SpacePak pre-sale team, reach out to them if you have questions for design applications and whatnot. And obviously there's technical service too if you're working on a project and you have tech service, and your rep and SpacePak Tech are the ones for you there. I want to talk a little on contractor locator map. So one of our main focuses over the last 2 years is to to help the industry get ready for these all electric hydronic projects. We've trained, I think it's over 300 contractors in the last 2 years for certification. If you're in our territory and you're interested in getting certified, give me a shout, reach out to us, and we'll get you involved in the next training. The certification trainings are similar to this, although they also go a little deeper on the technical. And we have a site visit where we inspect an installation and do some field training. When those two things are accomplished, the contractors have a certification which allows for extension of warranty on the units, which is great. I'm talking in a second on that. If you're an engineer, a homeowner looking for a certified contractor, please go to the SpacePak website, and it says find a certified contractor. You can put your zip code in, and you'll find all the folks across the country that have had the certification for the SpacePak products. Extension of warranty. So this is both non-certified and certified. One of the benefits of having a certified contractor do your project is you're basically doubling your warranty on the installed equipment. That's a big value. In addition to making sure it's installed right and operates well and is efficient, you're going to get extension of warranty. So a normal warranty on air-to-water heat pumps, inverter series air-to-water heat pumps, is a 2 years parts warranty and a 5 years compressor. If in fact you have a certified contractor, it goes to a 5 years on the unit and 10 years on the compressor warranty. So quite substantial increase on that. If it's a high velocity air handler, fan coils, associated equipment, it's a 1 year warranty with the extension to 5 years. And buffer tanks carry a 10-year warranty on all buffer tanks that are out there, regardless of who installed. So I think we're getting there. I'm a few minutes early, maybe 5 early here, but really happy to present. Hopefully it was a great value for you. A couple little things here. Follow SpacePak on social media here. If you're in our territory, you can follow us on Flowtech for updates on products and training events, as well as obviously Small Planet does a great outreach. So reach out to them and make sure you're on the Small Planet newsletter. I learn things every time I read one of those. I get some great insight. So those are fantastic. So with that, I am done with our SpacePak portion of the presentation. And what I will do now is stop the screen share, and I will let Eva take over. So thank you so much for everything here, and please reach out to us for questions, and happy to support Small Planet here in this presentation.
So everyone, here's Brighton. And originally you may remember that we talked about that we were going to be doing this at the Advanced Energy Center. And unfortunately, because of Omicron, they are not open, but you are still going to get a tour thanks to Brighton and also Chad. So take it away, Chad.
Well, welcome to the Advanced Energy Center for Sonoma Clean Power. We're in downtown Santa Rosa. This here is our water savings area in the Advanced Energy Center, where we showcase emerging technology types like the heat pump water heater. We have a couple different types of water heaters here. We have the grid interactive water heaters, as well as we have Small Planet Supplies Sanco, which is this water heater has no refrigerant. So we have emerging technology types like this water heater that is going to be a new way of having water heaters for our future. We have a heat recovery dish machine. This is a commercial dish machine that only uses 15 quarts of water a day. But more or less what this Advanced Energy Center is this is a center that we built after the fires from 2017. So over the last few years, we've been building this center as a showcase for emerging technology types. All of our technology types here are electric only. There are no fossil fuel or no gas appliances at this center, because this is what we are hoping in California is going to be, according to REACH codes and others, this is how we're planning to build our homes and businesses going forward with this all electric. So we have those solutions here. This is also an education center and a hub to teach the building community on how to learn to do better installation practices and others. So we do have a state-of-the-art education room in here where we'll teach those installation classes and teach the building community on how they can be connected with new emerging technology types to put in their homes and businesses. But you can come here to this center to learn any of those installations and get those certifications. We have a demonstration kitchen for the new type of cooking, which is this induction stovetop. This is a magnetic form of cooking. It's 90% efficient. So if you're comparing that to a gas stovetop, which most of us use gas to cook with, that is closer to 30 to 40% efficient. So you're losing almost 70% of energy out in the air. That's why your kitchens heat up. But this is 90% efficient. So it doesn't heat up your kitchen. It's a lot safer. It's a lot more efficient. And we will have chef side-by-side cooking events here and showcase on how you can install these as well. But we'll showcase ways of doing electric vehicles. So all of the EV market is displayed here and how you can get into the battery storage, home battery storage, EV installations. And then over here on this side of the Advanced Energy Center, we have new heating and cooling solutions for your home. We have the heat recovery ventilation system, which is a Small Planet Supply is also another one of their technology types here. We have the Chilltrix outdoor system. We have some mini split air to water heat pumps. We even have displaying and functioning in the space some ductless mini splits. And then we get into a hydronic system here from Flowtech. This hydronic system talks about how you can have 3 systems in one working, where you can both heat and cool your home air, as well as the hot and cold water for your home, all in one system. And this is a floating display of that here. But more or less, when you come down to downtown Santa Rosa and you come to the Advanced Energy Center, you're going to have the one-stop shop of being connected with the technology types. We connect our customers with these list of certified installers who can install that for them. And you get connected with educational opportunities to know what's the newest, latest, best thing to put in your home and business. But this is the Advanced Energy Center.
Thank you. If you are not in Advanced Energy Center service area, I'm sad for you. And if also would encourage you to see what your utility companies can do to let consumers know that there are options that are fossil fuel free. And I just want to thank everyone for coming to for our webinar today, and remind you that we'll be sending out the slides probably tomorrow and the webinar itself next week. And unless there are any other questions, we're going to let everybody go 15 minutes early. I want to thank Chad and Brighton for giving us the tour, even though we couldn't be there in person. Have a great day, everyone. Take care.
Great. Thank you.